Okay, I have straight up 1 o'clock, so let's go ahead and get started with today's webinar. Good afternoon and welcome to our webinar series, Navigating the Digitalized Industrial Landscape, presented by Phoenix Contact. My name is Gary Huey. I'm with Springfield Electric and I'm your host. Today's session, Life on the Edge, Your Gateway to the Digital World, expands our discussion regarding the industrial Internet of Things and edge devices. In the next hour, you will hear more about what an edge device can do for your operation, data collection, storage, and analytics. A few housekeeping notes. We will have time at the end for a question and answer session. Please type any questions you may have in the chat box as we go. I have muted all attendees for this presentation, and you can unmute during the question and answer session if you would like to talk live at that time. To make you aware, this session is being recorded. If you would prefer to discuss any questions one-on-one, we can offline after this session. So now let's go ahead and introduce today's presenter. Today's presenter is Ted Thayer. Ted is an automation sales engineer for Phoenix Contact, specializing in controls, web panels, HMIs, and IIoT. Ted has a diverse 23-year background, including software engineering and MES implementations. Ted, please take it away.
All right, thanks, Gary, and thank you for everyone who has taken the time this afternoon to come and check it out and hear what we've got to say. I was just thinking about Gary's introduction there, and 23 years in the business, just working with automation and machines in the field. It seems like yesterday, but it's been a little while. I want to take you just for a brief moment to 1998, when I think I built the most important machine that I've made. Kind of a small machine, a wooden box with kind of a trap door in it, a micro PLC, a couple of sensors, a couple of small electric drives, and a Sony Walkman that was controlled by the PLC. I had my, at that time, girlfriend open the box, trumpets and violins started playing, a little platform opened up, and out of the hole came a black cushion with an engagement ring on it. And that was how I proposed. So I always like to say, I took my love of automation in order to set myself up with the love of my life. So that was one of my first machines, and I've just always kind of continued working with automation ever since. I'm going to move on to the rest of my presentation here, and I'm going to go ahead and momentarily turn my camera off to conserve valuable bandwidth space. But yeah, here's the agenda today. For those of you that have been attending the IoT seminars that Springfield's been putting on over the last couple of weeks, just want to do a quick IoT review to cover those. And if this is your first one, just kind of give you a little bit of an idea of why we believe IoT is important. And then I will be jumping into my particular topics pertaining to edge devices, what they are, why you should use them, and to give you a few examples of these devices along with some use cases as well. So, I mean, the first big question, what is IoT, of which edge devices are a part of it? It's the Industrial Internet of Things. So as you can see here, we are talking about devices that are intelligent devices. They are networked together. These devices can monitor information and process information. They can take raw data and turn it into useful information. Ideally, this information can be used to improve your processes, and this information can be viewed and studied by management in order to make decisions about their processes. So an ideal industrial Internet of Things kind of allows you to accomplish all of these different characteristics. Here's kind of an example of what an ideal IoT system in the field would look like. Notice you've got conveyors, you've got manufacturing cells, You've got AGV robots moving around. You've got intelligent tote systems that are moving tote boxes around to supply the parts that the AVGs can pick up. Notice that all of these different devices are communicating by various methods. They might be going wired in between machines, or they might be communicating wirelessly. You can see the cool wireless animations here. As they're collecting information, passing information back and forth between each other. AVGs are being told where to go. The totes are being told what parts to pull. These machines are tracking what they're producing and manufacturing and sending all that information back. So this is a very lovely IoT system. It kind of almost brings a little bit of a tear to my eye to look at this graphic. So why do we want to do IoT? I mean, I described what it is, collecting a lot of information and processing it and sharing it over networks. Those networks could be private or they could be out to the internet. But why do we want to do this? What are we trying to hope to accomplish? These here, based on my research, are some of the goals that I've come across for IoT, what we're hoping to achieve. I'm not going to run through them point by point, but just giving you some general ideas. These first couple of points kind of talk about how it's very important maintaining your uptime. If a machine is not producing, you're not making money. If a machine should crash during production, that could even cost you additional money. I'm thinking of like plastic extrusion systems, which can take several hours to power up and begin producing the plastic. And if anything should interrupt that for any reason, it can take quite a while to get production going again, along with all the cleanup that needs to take place with that sort of thing. So how do you avoid downtime? By being able to implement predictive maintenance. That's probably one of the single biggest things I've been seeing with IoT is the ability to monitor a machine, and even though there's no apparent issues in the production or to the eye of the operators, maybe we're detecting things such as extra vibration in spindle or rotation machines, maybe some extra large, much higher temperatures to indicate that there's rubbing or friction. A good IoT system can spot these things that are occurring, and then as a result, operators, management can be notified, and then planned downtime can occur where they can jump in and replace and fix these systems before any actual unplanned downtime happens. These next couple of points essentially deal with taking an existing machine and hopefully just adjusting a few parameters or making a few changes, you can increase your throughput, which means more money. You're making more production. And that could be just adjusting the thrust of a machine, or it could be just adjusting, the time that you're spent, say, heating up something, or a delay or a wait, collecting this type of information. An example that I have from my contact lens manufacturing days, we were running a machine 24/7 and just not keeping up with necessary production. So we began running some tests. One example was to take the lenses off the cuvettes that they were in. It was necessary to squeeze them 3 times in order for the pumps to pick up the lenses and move them. We reduced that to 2 squeezes and ran our quality testing and analysis and found that we did not increase any waste. We did not incur any quality issues by doing that. So we reduced our time by a significant amount because those squeezes were very slow and methodical. Another thing we did was that we found that there were several processes that were running consecutively. We were able to take most of them and run them in parallel and just kind of connect up at key points in the process. Between these 2 changes, we were able to increase the production of the machine by 66% just because we reduced the time that we were wasting. So you take this and use this over large systems, and you can see some real massive time and process savings, which can lead to reduced waste and just more money, more profit. So fleet and asset management is kind of referring to your mobile assets. Could be trucks, trailers, forklifts, maybe flexible manufacturing cells that you can move around. You can ascertain and get a big picture view of how your parts and your processes are moving, and you can make adjustments based on that. Enterprise integration refers to the ability to take an IoT system like a plant floor and integrate it directly into accounting, purchasing, logistics, so that that decision makers there can be working with real-time information on what exactly is being used, what is actually being produced, not waiting for daily, weekly, monthly reports, but getting actual real-time information and being able to make adjustments for that. Remote connectivity, I won't cover this too much. Dave covered this pretty well last week, but just the ability to remotely log in to troubleshoot a system without jumping in your car and driving there, or perhaps flying there. If you're a machine builder and you're troubleshooting a distant machine, being able to connect up. New revenue paradigms, a trend that I've been seeing over the last 2 or 3 years is the trend towards renting machines based on production rather than making a customer do a large one-time purchase and then you sell service contracts. There are a number of customers who, they just kind of balk at making a large one-time purchase. It'd be nice if there was some way to amortize that over time. And so what we've been seeing, especially in food and bev, a customer gets a machine and they essentially rent it. I have my camera off, but I'm making air quotes here. So as they're making whatever it is that they're making, could be bread, could be bottling, what have you, that production is being tracked. And with IoT, the production can be stored in a cloud where the machine builder can access that information and based on that, essentially charge a customer rent, or they can charge them a fee based on what they produce that week, that month, that quarter, what have you. So it's kind of an interesting new approach to selling equipment, and it's been entirely enabled by IoT. So now that we've kind of defined what IoT is and why this is something that would be interested in, the next step is to kind of talk about edge devices, which is my specific topic today. So in a way, I think the best way to explain what an edge device is to first of all, go through what it is not. So if you take a look here, this is kind of our traditional automation setup. You've got your field devices, pumps, motors, sensors, valves. You've got a PLC or multiple PLCs or other controller devices that are reading reading the information and according to a program, activating various devices. And then hopefully, not in all cases, but hopefully that information is being looked at and stored somewhere by a central SCADA system, maybe archived in a historian. And hopefully, but often not, this information is going to be looked at and studied by someone later who goes through and just takes a look and looks for trends. So that's kind of the traditional automation system. Where cloud devices come into play, and this is going to be different from an edge device. We'll talk about cloud devices. This was a way to start trying to take those traditional automation systems and begin adding at least elements of preventive maintenance. That's been the primary focus of cloud devices in automation in my experience. So you've got, for instance, robots. They might be outfitted with, say, a temperature sensor or a vibration sensor. Those are a couple of very common products. These sensors collect information and they send it up into a cloud where the data can be stored and looked at later. Hopefully it's being dashboarded to where someone can take a look and get a quick glance and see anything that might be of a concern to them. So with these cloud devices, notice I've got arrows going into one direction. Typically cloud devices go directly to a cloud and don't really deal much with the intervening plant floor. So just to give you some bullet points you could look at later for cloud devices, They connect to the plant floor. They connect to a cloud. They send information up to a cloud. That cloud will be running software to do the analytics and the algorithms to help determine if there's any issues that need to be looked at. Notice that they do not typically provide real-time feedback to a control system. I attended a smart production show a couple years ago, saw a number of these devices. I was curious about interfacing them with our PLC Next product. Most of those devices connected to a cloud. There was no real-time access to them. Along with the devices, a lot of these manufacturers were selling the service of monitoring the data and making sure that they informed their customers of any issues that arose. So these devices typically go one way, and the actual devices themselves, the vibration, the temperature sensor, don't really have any onboard decision making. You know, they're really the gateway to the server that does. And as I mentioned, these are typically subscription services that you pay for in an ongoing format. So while cloud computing and cloud devices have definitely done a lot to move the cause of IoT by implementing predictive maintenance, there are definitely a few issues. For instance, should you run into any latency or bandwidth issues, it won't be as effective. Should you, for some reason, lose your connection to the cloud, you'll lose your internet service provider, those devices don't have anything to talk to. They're essentially useless. So this is where it was discovered that to really carry IoT further, there was a need for some kind of a device that could keep the data closer to home and maybe make a few decisions on its own. And so that's where this idea of an edge device comes into play. It kind of sits at the edge of the OT, which stands for operating floor or operation floor, or operation technology, that is the production part. And it sits between there and the edge of the outer world, your cloud layer, which is kind of your IT layer. So these devices kind of sit in between and provide some of the services of cloud, and then can also provide some capabilities for the floor. So it's an interesting concept, and here's a place where the role of IT and OT kind of sort of run together, and maybe organizationally can get a little messy sometimes. So some specific characteristics of edge devices. They should be able to run algorithms and perform data analysis and manipulate data. You know, they are there to provide some of the features that have been typically placed on the cloud. They should definitely have onboard data storage. Say you are utilizing a cloud and there is a disconnect, it needs to be able to archive information for quite some time until it can connect to the cloud and report. Also, these algorithms do require extensive data to look at, so you need to be able to store that data. An edge device should be able to provide real-time feedback to the control. If you're detecting an out-of-spec spindle, you could choose to immediately react and conduct a controlled shutdown to that line, for instance, so that you can get it taken care of. So because these devices do talk to both the plant floor and talk to clouds, it is important to make sure you have a lot of communication options. And it's also important to have strong network security, just because of the fact that these do sit on your operating floor and do talk to the outside world. You know, they are a point for attack by hackers or other ne'er-do-wells. So it's important that they can protect themselves. So this last point here is not really a feature, but rather my comment that if you're going to start using edge devices, try to do the best you can to future-proof your investments. Once you put them in, you want them to be able to change with the times and the technology, which, as we see, changes very frequently. So how does future-proofing look with an edge device? Part of that would be just being able to speak quite a number of different drivers, you know, talking to both devices on the plant floor and being able to speak protocols to go out to remote devices. The plant floor, I've got a couple listed here, like Modbus, or Profibus, which are a little older, Interbus, and people might be like, what are those on there for? you know, in the typical world, if you decide you're going to be adding edge devices, it's going to be sitting on top of legacy equipment that has been around for a very, very long time. If you attended Dan Schaefer's seminar the first week, he kind of talked about that. You've got devices that are speaking HART, that are speaking Modbus, you know, a lot of old protocols that have kind of fallen out of favor, but they're still there. And just because there are thousands of these devices, you know, it's just easier to be able to talk to them rather than throw them out. But then it's good to have current protocols so that you can keep up with the technologies that changes. So an edge device should have a nice open platform so that you can update as communication technology changes. So the previous slide, we talked about the protocols. In this slide here, it's just important to be able to have the different media or methods in order to interact with cloud devices. And it's important that your device can be flexible in order to speak these. You know, I'm speaking from a little experience with Phoenix Contact. A couple of my networking coworkers are sitting on the call, and so I'm like apologizing, but we kind of got caught for a little while when the world transitioned from 3G to 4G, and it took us a little while to catch up and adapt. So that was kind of a shame, but you know, fortunately we learned our lesson, and now we're on boards for 5G and other types of technologies, so that we'll make sure we're always abreast and aware of things. But it is important that your edge device can be easily adaptable to different types of not just communication protocols, but also different types of communication media. You know, one of the keys to a successful edge device is being able to run the types of algorithms that would typically run on a cloud, you know, scaled down, not the full effect, but being able to run these types of programs. And so it's just very important to have a device that can speak a number of different languages and you know, work with a number of different communication standards in order to continue to function and to keep moving on and to change with the times. So what are some of the benefits of using edge devices? Implementing these, you know, the algorithms, implementing some of these different functions. You know, some of these I've already kind of alluded to, being able to store data locally, storing it closer to the point of origin, especially to guard against potential downtime with your networks or latency issues. That also ties into the offline processing. You know, if you lose your connection, being able to continue to run your processes and monitor them. Machine learning is a key one. The ability of an edge device to store data from its processes and then improve its function is a key benefit if you figure out how to enable it properly. An example that I can give you is I've been working with a company that takes soybeans and it's turning into ethanol and biodiesel fuel. And part of what they are looking at us for is the ability to take a batch of soybeans, analyze it, look for the humidity, look for the moisture content, the weight. There's a few different quantities that check for there. And then as they've been doing batches over time, it's been learning as it reads this set of characteristics, it's been making changes on its own. You know, maybe I run this process a little longer, maybe I cook it a little longer, maybe I tweak my temperature. So that way they can drop in a batch of soybeans and it gets extracted in the best possible way because it learns over time. Very cool functionality. Event processing is kind of ties into machine learning, but in a bigger, more unpredictable level. Event processing, or more accurately, complex event processing. You know, if you've got a majorly skewed data point, being able to react to that in a proper manner. You know, so for instance, if instead of soybeans, for some reason, somebody dumps in a bunch of corn or green beans or whatever, you know, being able to see that and understand what's going on and take all the appropriate steps to react to that definitely takes sophisticated processor and good algorithms, and a good edge device provides that for you. Programming collaboration, you know, when a software engineering team gets together to work on the latest version of Windows or Word or Excel, you've got a number of people working on that project. Oftentimes in the industrial automation world, programming tends to be fairly solitary. You've got a guy working on the HMI, you've got a guy working on a PLC program, et cetera, et cetera. Not always the case. Good integrators can work together, but there are a lot of rules that they have to put in place in order to successfully collaborate, say, on a ladder logic PLC program. A good edge device allows for an easier method for multiple programmers to work on these applications and to work together smoothly. So lastly, a good edge device allows you to develop your code in the languages that you prefer or in the languages that most suit themselves. You know, different languages, Python, C++, Node-RED, each have different strengths, pluses and minuses, for instance. And being able to pick the appropriate language to develop your application in is key to successful edge device implementation. So giving you a few examples here, I will be primarily talking about Phoenix products and some Phoenix applications I've worked on, because that is where I spent the majority of my IoT time. But you know, for us, we do have a sliding portfolio of devices from our lower end PLC Next controllers on up to small industrial PCs that we are using as edge computers. So when I talk about anything with an AXCF in it, these are kind of a unique device where it's essentially a Linux computer put into a PLC format. So that way this could just be a powerful PLC that's running your ladder code over and over and over again, or it could function as an edge device and take data and send it up to a cloud, or to run some of these algorithms, pulling in vibration sensors and that sort of thing, and providing services and real-time feedback to environmental conditions. So kind of a unique thing to us, you know, and then on up into the edge device computers that I'll talk more about in a minute. So just giving you a little idea of the specs of one of our edge devices, the AXCF 2152. That was kind of a mid-range controller, was in the middle of my chart. As you can see here, it runs an ARM chipset, which ARM chips are very flexible and definitely able to meet all the different requirements. And in addition, they're relatively low power. You know, sometimes we deal with power constraints, and that does certainly help. So as you can see, we've got a pretty good chunk of memory here for doing the data storage. Through some tricks, we could also access USB if you need even more. As far as collecting data, of course, we can do a number of different networks. I'll talk about those in a minute. But these particular devices can also have up to 4,000 I/O points connected to them. Could be reading alarms, could be reading analog signals, temperatures, speeds, and all that information could be gathered in, analyzed, or sent up to a cloud, for instance. A little further up the table, we have our PLC Next technology devices, which are more PC-based. These are extremely new, and you'll be hearing more about them eventually. Being PC-based, they have quite a bit more memory, more flexibility for running algorithms, additional ports for taking data and moving it around, but they are running the same type of real-time control engine. So if you wanted to connect remote I/O and do real-time machine control along with your IoT functionality or analytics, you know, these are more than capable of doing that. So talking just a little bit more about the PLC Next, because that's really these devices, the AXCF family, really one of our key products and one of our key differentiators is that, yes, it's small, you know, it can fit easily inside of a small control cabinet, And yes, it can run a machine, it can read I/O and turn on devices in real time. So it can be programmed in ladder, but it is capable of being programmed in quite a number of different languages, uses a number of different protocols. As a matter of fact, we can run other people's software right on it along with our own. So this is definitely a PLC and a cloud device all together in one. That's very easy to future proof because it does have this flexibility to run these different languages. Recently, we're asked about running a software language called R, which is a heavy data analytic language. And we found that we are able to do that with just a little bit of manipulation. I talked about the importance of security on an edge device, and here's a great example. This is built right into all of our PLC Next products. We do have firewalls. We have the ability to do certificate exchanges. We meet a number of important security standards. And then as far as talking to clouds, we have developed a number of routines in order to talk to these different clouds, store data in them. The Profi Cloud is one of our specific clouds that we've developed at Phoenix. It's so well integrated, it's just simply checkboxing inside the PLC Next, and then you're taking data and storing it up into a cloud and having it dashboarded for a remote manager to look at and make decisions. I was going to step over just briefly to our BL2 BPC 1500s. These are actual PCs. We call them edge computers. It runs Windows 2019 currently. And these are true computers, very small and very compact, but they meet all the requirements. They can do your analytics. They've got extensive onboard data storage. They're very compact, and so they can be put into tight locations. So I saved this kind of for last because honestly, there are a lot of edge devices out there, similar to this. I think ours is more rugged. We offer some nice warranties, but oftentimes if you start Googling edge devices, you'll see information for a number of different small PCs out there that will provide this type of functionality. Kind of stepping back to our PLC Next devices for a little bit, one thing that just, in my opinion, makes them unique to be considered is you can use the same piece of hardware in multiple different ways. If you're just doing basic machine control, no problem. This device could do that. If you need a true edge device functionality where you're doing machine control as well as interacting with the cloud, running different algorithms and reporting them to IT, you can do that with the exact same piece of hardware. If you're already very well versed, we use Allen Bradley, we use Schneider, we use Mitsubishi, no problem. You keep that in place. Using the exact same piece of hardware, you can interrogate that PLC, and then you can do true edge device functionality where you're pulling the information, acting as a gateway, writing up to a cloud, sending it to a PC, sending it to IT systems. So as far as where as a company and where I personally have been seeing some interest in edge devices, actual applications, ExxonMobil picked us because of our ability to run different algorithms and being able to reuse existing code that they had and being able to run it on our hardware. That's not anything that I've worked on, but that is one that I like to talk about. Most of the rest of these I've worked on in some way, shape, or form. This environmental consulting service, they're the ones that were needing cloud data and the ability to run our programming language. This warehousing OEM is a very interesting one because it is showing the ability to be both an edge device and a controller. It's running conveyor systems, intelligent conveyor systems. You plug in a section of conveyor system, it reports to the PLC, I'm here, and then the PLC knows it can start using that. On the other side, it is talking to an Azure cloud where millions of SKUs part numbers for whatever retail place we might be doing this for are stored there. And as products are being read, it's accessing the cloud and saying, oh, that's a pile of wrenches, and it will direct it to the proper place. So it allows the corporation to just update the cloud with new products, new parts, new locations, and then that's available to every warehouse, every location, without having to go through and do major updating. Another favorite one here is the pizza maker. There is a national pizza company that has locations all over the US. And one of their goals was to make sure that whether you were in Maine, Texas, or Washington, you were getting the same great pizza every single time, regardless of time of day or who was doing it. And they worked with us to do that, partly because we could communicate in a number of protocols like CAN that aren't all that easy to get on PLCs. But then in addition, we could talk to their third-party cloud where they were updating the recipes and when one spot, and that got downloaded to all the different locations. So temperature, cooking time, the amount of cheese that got sprinkled on there, slicing the pepperoni and sprinkling it on. They found that we could do that very easily for them. You run the machine as well as interfacing with the cloud. So, hopefully while I've been talking, you've been kind of reading over these some of these different applications, because I wanted to make sure that we had some discussion and question and answer time. So here is time for your questions, and here's a little plug for what we're going to be talking about next week. Thank you.
Thank you very much, Ted. That was great information and some really good examples. Really appreciate that session. We're going to go to the chat box first to see if there's any questions that we have there, and then we'll open it up for live questions as well. And we do have a couple questions in the chat box. The first one came from Dan Schaefer, and Dan says, "Hey Ted, I see the Docker well on a number of slides. Can you give a little explanation on what that means?"
Oh, sure. Yeah, the Docker is, if everyone on the call, I don't know, if you're familiar with the idea of a virtual machine, the ability to kind of have a little mini software environment inside your PC, maybe where you run some older legacy software that Windows doesn't currently support, for instance. Docker is essentially that for industrial automation. So for example, our PLC runs a distribution of Linux called Yocto. If someone developed this interesting application for Linux 32, normally to make it work on us, it would be necessary to do some significant software re-engineering in order to convert it to run from that operating system to ours. With Docker, essentially, you've got this package, you can put in the program that you want to actually run, and speaking simply here, but putting in a dab of the OS that software is supposed to run for, that's all encapsulated inside this package or this container. You can drop it into our PLC and then go ahead and run that application regardless of the original OS with a very minimal amount of re-engineering. I won't say no re-engineering, but a very minimal amount compared to re-engineering it from scratch.
Great. Dan was, I remind everyone that you are muted, so if you do want to talk live, just unmute. Dan, did that cover everything that you were looking for?
Sure did.
Thank you. Next question comes from Logan Mueller. It says, other than ladder, what is the most common programming languages you see?
Oh, good question. It sort of depends. I'm going to say there are two that I run into quite often. I would say probably the most popular one is Python, which when I went to school, I graduated from engineering school, I learned Fortran, which I don't think anyone knows about that one anymore. I learned C, I learned assembler. So Python is kind of a very popular language currently. It's kind of like C, or maybe C++, but without all the, I would say, without all the handcuffs on it. You don't have to declare too many variable types. You can just start using things in arrays and lists. So I think that's probably the most popular language. And then we do see a lot of C++, just because that's one that's been taught for a pretty long time. And so it's out there, it's very compact. Our backplane bus actually speaks C++. So if you're a good coder and you use our instructions, you can talk to our IO right directly to the IO from a C++ program without needing to use any other software in the way.
Very good. Logan, did that answer your question?
Yeah, yep, I think so.
All right, great.
Thanks for submitting the question. Our next question comes from Damian Honings. He says, I think I saw that Linux is the operating system for the PLC Next. If I saw that correctly, why Linux instead of Windows?
Okay. Well, first of all, we do also have Windows, although it's mostly on the PC, like the BL2 that I talked about. With our PLC Next platform, we do use Linux. You were right about that. The reason why we use Linux is a couple reasons. Number one, it's very small and very compact. Since these aren't full-fledged PCs, you need a good, stable, small software, and Linux is very stable, very compact. The other reason is, in general, Linux for networking purposes is considered a much safer, more secure OS in terms of network security. Much more difficult to hack or penetrate, partly because there isn't as much Linux as there is Windows computers out there, for instance. So you'll find that a lot of IT security devices, routers, switches and such use some form of Linux. So it just really made sense to use that for our controller.
Okay, very
Yeah,
good.
thanks. Yep, thanks, Ted.
All right.
Thanks, Damien. Next question comes from Seth Herod. It says, you mentioned Node-RED, sorry,
Yeah.
a few times. I know it's sort of a visual programming language, but can you tell us more about it?
Okay. Yeah, you are correct. It is a visual programming language. It's kind of a flowcharting type language. And it's very popular these days as well. Maybe not up there with Python because it's a little bit more specialized. But essentially, Node-RED, if you can access a Node-RED programming environment through Chrome, and you've got a lot of little boxes and circles that are email, do SQL, perform some kind of a data operation. So you don't have to write all that code. You kind of drop these little code snippets in, connect them up, and you make this nice visual program where you see an input, ooh, do an SQL read, ooh, send an email. And so you can kind of lay it out very simply. It's a very collaborative environment. You see engineers developing code snippets and posting it in the Node-RED library. Before we implemented Ethernet IP in our firmware, we found a Ethernet IP driver someone had built in Node-RED. And just for kicks, during a slow trade show, we were able to integrate it in. We were running Ethernet IP in just a few minutes. So very handy for doing just specialized connections. You can go through there and borrow other people's work. There are hooks for Alexa. That's another one. We've got customers who are trying to build voice commanded machines where you say start, stop, or what have you. They're using an Alexa or similar device. Node-RED offers the hooks to take that information and put it inside a PLC program to do something. So we're actually seeing some voice controlled manufacturing. Very cool that you can do with Node-RED.
Great. Did that answer your question, Seth?
Yeah, absolutely.
Okay. We have, thank you for submitting that. We have another question from Robbie Bauer. Do you have any examples of Node-RED programs to share?
We do. What I've been trying to do is, well, not just me, but other people in my team, solution engineers back behind us, we're trying to take some of these and just document them a little bit better. If you were to go to GitHub, for instance, we do run a USA GitHub website, and there is an example there for doing some Node-RED programming, how to put it on there and actually run it. So yeah, we do have those. We're trying to formalize some of our documentation to make the examples a little bit more useful.
Did that answer your question, Robbie?
Yep. Thank you, Ted.
Yep.
Are there any other questions out there? Thank you, Robbie, for submitting that. Okay, well, hearing none, we'll go ahead and close it out. Springfield Electric, in partnership with Phoenix Contact, can assist you in these solutions, including the specification, design, and implementation. In closing, we appreciate you joining us this afternoon. We will be sending a follow-up email with information about what you saw today and a short survey. Your feedback is very important to us. Next week, Thursday, October 22nd at 1 p.m. Central Time, we will host our 4th session in this webinar series, Stop the Spread of Viruses. No, it's not COVID. Please register for and join us next week. I'll see you there. Goodbye, everyone.